Okay, so here on the screen you can see our differential signal. So here's the J2154A single-ended TDR. The splitter is separate in this one. And here's the J2154 fully differential. That one has the splitter built in. In fact, the two biggest differences between these two TDRs, one is that the differential device has much lower jitter than the single-ended device. In fact, more than an order of magnitude lower. Also, in a fully differential device, the splitter is included inside the device, while in the single-ended device, it's external. I just wanted to show this picture, even though we're going to be making all single-ended measurements today. So here on the left side, you can see the pulse. And in fact, right here on the screen, at the left edge, that's the launch of our pulse. You can see the two complementary signals. The middle trace is the reflection coefficient ρ. And as you might recall, ρ has a value between -1 at 0 ohms, +1 at infinity ohms, and a perfect match is 0, right in the middle. We use another math function to transform that to impedance. We have a 50 ohm differential device, and you can see I have a cable on each one of those outputs. And so we expect to see a differential impedance of 50 ohms plus 50 ohms, or 100 ohms. And here you can see on the screen, we're showing 102.6 ohm differential, or about 51.3 ohms per cable. And that's about right. I just wanted to show you what that looks like. We're going to actually be making single-ended measurements today. So we can get rid of one of these cables. And in doing so, now you can also see where it is that the cable was. Now we can see a very short launch there, which is the 50 ohms. In order to make this easy for us, I'm going to be using setup files. Once I get our measurement set up the way I like it, it's really easy to save the setup file and then recall it when it is that I want to use it. So the first thing we're going to look at is, let's go ahead and look at the TDR bandwidth, because we keep talking about bandwidth. And in fact, one of the benefits of TDR is that it does give us an awful lot of bandwidth for the money. We're also going to need to connect this at the other end to our oscilloscope. So we're going to use a second channel here. And now you can see my two channels on the oscilloscope. Now, how do we measure bandwidth? Well, the way we're measuring bandwidth is we're taking the differential of this edge. It's a really fast edge. But we take the derivative of that, and then we do the FFT of the derivative. You can see in the upper trace, that's a 0 dB signal. And it's flat with just a couple of wiggles all the way out to 10 gigahertz. Part of those wiggles are my cables and my adapters. But that's just okay. So we have almost 10 gigahertz of bandwidth, just like I said. That's for the oscilloscope itself.